Hello, today I'll be going over 7.1 and 7.2. 7.1 is apply the Pythagorean Theorem. So, oops. This is for right triangles. So it needs to have a right angle. We'll call A and B the legs and C the hypotenuse. So C is always the one across from the right angle or the longest side. So the Pythagorean Theorem is A squared plus B squared equals C squared. And for area of triangles, let me draw a picture of a triangle really quick. So this here is the height, and the bottom is the base. So the area is 1/2 the base times the height. So the height always has to make a right angle. If it doesn't, that means it's in the middle like this. But if it's a right triangle, then it's just the other leg. Okay, so here we have some problems. We want to find x. In number 1, x is the hypotenuse. So that would be 33 squared plus 56 squared equals x squared. So then we would get 3,136 plus 1089 equals x squared. And when we add those together, we get 4,225. Then to solve for x, we're going to square root both sides. So we get x equals 65. For number 2, x is a leg, it's not the hypotenuse. The hypotenuse, again, is the longest side, or across from the right angle. For this problem, it would be 68. So we have x squared plus 60 squared, that's the other leg, equals 68 squared. So we have x squared plus 3,600 equals 4,624. Then to solve, we're going to subtract 3,600. So we get x squared equals 1024. And then square root both sides, and we get 32. Number 3, we have a square on the left, so that means this would be 6 and this will also be 6. And then if we look at this triangle here, this makes a right triangle. So that means we can use the Pythagorean theorem. X is the hypotenuse, so we have 3 squared plus 6 squared equals x squared. So that's 9 plus 36 equals x squared. So x squared equals 45, and then we're going to square root both sides. And now I'm going to break up 45 because that's not a perfect square. So 45 breaks up into 9 and 5, and 9 breaks up into 3 and 3. So since this is a square root, we're looking for pairs of a number, so we have 2 3s here, and then this 5 is going to stay on the inside. So that means x will equal 3 add 5. Okay, number 4, we have a couple of unknowns. We have x, and we have the side length I'm going to call y. So in this triangle here, we have 2 things we don't know. So we first actually have to find y using the left triangle. So we can use the Pythagorean theorem. 5 is the hypotenuse, so this would be y squared plus 3 squared equals 5 squared. So we get y squared plus 9 equals 25. Then we're going to subtract 9, so we get y squared equals 16. Square root both sides, so we get y equals 4. So now that I know what that is, I can solve for x. So that would be, x is the hypotenuse. So 4 squared plus 7 squared equals x squared. So we get 16 plus 49 equals x squared. So we get x squared equals 77. And then we're going to square root both sides. 77 breaks up into 7 times 11, and both of those numbers don't break up anymore, so there are no pairs. So we can leave it as the square root of 77. Okay, this last section we want to find the area. So we have to find the height, which is h in red here. We can actually write this as, or we can create like a triangle here that is a right triangle. So 20 would be the hypotenuse, and it would break up the base into 2 equal pieces. So this would be 16 and this would be 16, because 16 plus 16 is 32. So to find h, we could use the Pythagorean theorem. That would be h squared plus 16 squared equals 20 squared. So that's 256 equals 400. Subtract 256 on both sides, and we get h squared equals 144. So when we square root both sides, we'll get h equals 12. Now to find the area, that's going to be 1/2 base times height. Our base is the entire bottom, which is 32, and our height that we just found is 12. So once you multiply that out, you'll get 192 feet squared. Oh, I think I forgot to add this, but to find the perimeter, that means we're adding up all the sides. So for the perimeter, that would be 20 plus 20 plus 32. So that would be 72 feet. So let me just add that really quick. Find the area and perimeter. Okay, next we have a leg that is 15 feet and an hypotenuse that is 39 feet. So I'll call this one X. You can choose the bottom one too if you want. Doesn't really matter. This is 15 and this is 39. So first we have to figure out what X is. So that'll be X squared plus 15 squared equals 39 squared. So then that's 225, and 39 squared is 1521. So then we get x squared equals 1296, and then when we square root both sides, we get x equals 36. So a way to check your answer is if x is not the hypotenuse, it should be shorter than the hypotenuse. So our hypotenuse was 39 and 36 is less, so we did this correctly. Okay, so to find the area, that would be 1/2 base, which is 15, times the height, which is 36. Because we know this is 36 feet. So then we'll get 270 feet squared. And then for the perimeter, that's adding up all the sides. So that's 15 plus 36 plus 39, which is 72 feet. Oh wait, hold on. I think that's wrong. Just kidding. It's 90 feet. So perimeter equals 90 feet. Okay, so that's it for 6.1. 6.2, we're using the converse of the Pythagorean theorem, so that's just like backwards of the Pythagorean theorem. That means if a squared plus b squared equals c squared, then it's a right triangle. And here I've included a table of different types of triangles. If it equals, it's going to be a right triangle. So that's the converse. If the hypotenuse squared is less than a squared plus b squared, then that means angle C is an acute angle. So this will be an acute triangle. And if it's greater than, it'll be an obtuse triangle. So for the examples, for number 1, we want to tell whether the triangle is a right triangle. So we want to plug this into the Pythagorean theorem and see if it works. 89 is my longest side, so that's going to be my C. So we have 80 squared plus 39 squared equals 89 squared. And then that's going to be 6,400 plus 1521 equals 7921. And when you add these, you'll get 7921. So that means yes, it is a right triangle. Number 2, we have 4 rad 19, 14, and 10. So if you plug 4 rad 19 into a calculator, you'll get that it's bigger than 14. So that's going to be our hypotenuse. So we have 10 squared plus 14 squared equals 4 rad 19 squared. So that's 100 plus 196 equals, so a way to do this is to either plug it into a calculator, or you can kind of like distribute the squared. So 4 squared is 16, and then square root of 19 squared is going to be 19. So you could do 16 times 19, and you'll get 304. So we get 296 equals 304, which is not true, so it's not a right triangle. Okay, number 3, we're just given side lengths. If you plug 2 rad 34 into a calculator, that's going to be the longest side. So we have 6 squared plus 10 squared equals 2 rad 34 squared. So that's 36 plus 100 equals 136. So we get 136 equals 136, which is true. So yes. And then we have 10, 12, and 20. 20 is the longest side, so that's going to be our hypotenuse. So we have 10 squared plus 12 squared equals 20 squared. So that's going to be 100 plus 144 equals 400. So we get 244 equals 400, which is not true, so no, it's not a right triangle. Okay. In this last section, we want to decide if the segment lengths form a triangle, and if they do, would the triangle be acute, right, or obtuse? So we have to first decide if it's a triangle. So that's using the triangle inequality. So if you add up the 2 smaller sides, those should be bigger than the longest side. So 10 plus 15 is 25, and 5 rad 13 is about 18. So yes, it works. And we don't really have to check the other 2. So that means this is a triangle, and then we have to see what kind of triangle it is. So we have 10 squared plus 15 squared, those are the smaller sides, and 5 rad 13 squared. So I'm just going to leave a little like blank right here. And then we'll figure out like if it's equal, greater than, or less than. So that's going to be 100 plus 225 and 325. So we have 325, 325. So that means this here in the middle would be an equal sign. So since it's equal, that means this will be a right triangle. So I'm using that table that was included in the previous page. Oops. Okay, here is the last one, number 5. So again, we're going to check that the smaller 2 side lengths are bigger than the longest side length. So it'll be 18 is greater than 12, which is true. So this is going to be a triangle. So we have 8 squared plus 10 squared, and then 12 squared here. So that's 64 plus 100 and 144 on the other side. So that's 164 and 144. Oh, so don't forget this is the c squared. So it's kind of like backwards of how you see it on the table. So for this one, the hypotenuse squared is actually less than a squared plus b squared. So this is going to be an acute angle or acute triangle.